Hi guys, welcome to Inspired Physics. This is me Anakha Padmakuma. Today we'll be learning the next topic of Electrostatics 1, that is what is a dipole and what is dipole moment and what happens to a dipole when it's placed in uniform electric field. So these are the three topics and there are more topics under dipole. So in this video we will be learning these three topics. So let's move into the video. So, what is a dipole? The word dipole means two poles. Dipole, two poles. So, when there is existence of 2 point charges, that is, two charges are to be existed, then we can say there are 2 point charges in a system. So, when it forms a dipole, that's a question. When it forms a dipole, a dipole is being formed when these two charges are in opposite direction. That is, one of them should be a positive charge and the other should be a negative charge. That is the case when we can say that a dipole exists. And there is also more conditions when compared to dipole. That is, dipole can only orient in minus q to plus q direction. That is, only in this direction the dipole will be oriented, and there is also a specific amount of distance between them that is to be marked as 2a. So the distance between the dipole is to be marked as 2a. It is constant in every case. That is, all the dipole that orient in a system will be having a distance of 2a between them, and the direction of the dipole will be always in minus q to plus q. This is the kind of orientation, and this kind of orientation can be termed as a dipole. So, when we talk about the dipole, the net charges in a dipole. What is the net charge of a dipole? That is, the two charges that are present in a dipole are plus and minus. So, the equal amount of two charges, that is plus q and minus q, are being seen in the system in the equal amounts. That is plus q plus minus q. That is, these two are the charges that are being residing in the dipole and they are in equal amounts. So, on taking the sum, we get this becomes 0. So that means the net charge on a dipole is to be considered as 0. And we can mark the dipole to be as P, and it's a vector quantity. There is a dipole moment. Dipole moment is marked as a vector quantity and always takes the direction of the electric field. The electric field is the direction of the dipole moment. Since these two charges will be having a field of its own, and the net electric field can be termed as E. So the sum of the electric field becomes E minus Q plus E plus Q, which is equal to E. That is never equal to 0. That means the electric field of a dipole can never be 0. So these two are the conditions when we compare the dipoles. That is, the net charge of a dipole is always 0 and the net electric field is always E not equal to 0. So what is a dipole? Dipole are two charges that is oriented in a specific direction, that is from minus q to plus q, and having a certain distance of 2a, and this is to be fixed in every system. Wherever they occur, this will be the kind of orientation they take. So now we just learned that the net electric field E inside a dipole is equal to E plus q plus E minus q. And this can never be equal to 0 also. So this condition, since this condition exists in a dipole, the dipole has a turning effect. That is, when a dipole is being placed, it has a turning effect. That it turns. It turns when it's placed in an electric field. That we'll be learning in the next topic, that is what happens when a dipole is placed in an electric field, uniform electric field. So just remember, this is the reason, that is, electric field can never be 0. Electric field of a dipole is never 0. So that means when it's kept in electric field, it has a turning effect. Now let's move into the topic, electric dipole moment. Electric dipole moment is to be marked as P. I told you that it's marked as P, capital P, and it's a vector quantity, that is P. So this P is to be termed as the product of magnitude of either of the charges of the dipole. That is, the dipole consists of two charges oriented in this direction.
either plus q or minus q, both having equal a magnitude. That is, if this is 3 minus 3 coulomb, this will be plus 3 coulomb. Both magnitude are equal. So what is the dipole moment? The dipole moment is the product of the magnitude of the either of the magnitude of the charges and the distance between these two charges, that is q into 2a. This is called the dipole moment. And now let's move into the SI unit of the dipole moment. What is the SI unit of moment? What is the unit of coulomb? Charge, it's coulomb. And what is the unit of distance? It is meter. So the SI unit of dipole moment becomes coulomb meter. The C should be written in the capital form. Coulombs are always to be represented in capital form. Don't write it as small c. Small c represents, if it's written like this, it means centimeter. It's not centimeter, it's coulomb meter. Don't do this mistake. So what is the dipole moment? Dipole moment is termed as the product of the magnitude of either of the two charges, and the distance between these two charges of the dipole.
Now we are going to move into the last topic, that is dipole in uniform electric field. What happens to a dipole when it's placed in uniform electric field? For that, we are going to consider some electric field lines to be represented as straight lines. One line is enough to avoid confusions. Okay, two lines. So this is the electric field, and now we are going to place a dipole here. There is a condition in placing a dipole in an electric field. We have to place this dipole in making a certain angle. That is, the dipole should make an angle theta with respect to the electric field. When we keep this dipole in an electric field, it should be making an angle theta with respect to the electric field, and 2a is the distance between these two dipoles. Let's mark this to be AB. The dipole is AB. Now we are going to consider a perpendicular. That is being drawn from B to E. So this point becomes C. So from this we can find BC. How can we find BC? We can find BC by taking sine theta. What is sine theta? Sine theta is equal to opposite by hypotenuse. That is, what is opposite here? BC. BC is opposite, and what is the hypotenuse? 2a is the hypotenuse. So from here BC is equal to 2a sine theta. So what is the value of BC? The value of BC is to be marked as 2a sine theta. Now we have found all the quantities that we have required. Now we are going to move. I just told you that when an electric field occurs and a dipole is to be placed in it, it causes a turning effect. The dipole has a turning effect. That is, when a dipole is to be placed in an electric field, it causes a turning effect. That means it rotates. And tends to turn into the direction of and tends to form zero angle with the electric field. But it never happens. But it causes a tendency. Due to this tendency, there will be a force here and another force F here. Both charges will be experiencing an equal and opposite force. So due to this force, there is a generation of a couple. This couple can be termed as the torque, that is torque. This torque is what helps this dipole in creating a rotating effect inside this electric field. So that torque is to be marked as force into perpendicular distance. Force into perpendicular. Tau itself stands for force into perpendicular distance. So what is the force here? The force here is the force here is to be marked as F into what is the perpendicular distance? That is BC. That BC is to be marked as a perpendicular distance. Yeah, I hope you're clear with it. Please excuse me if there is any mistakes. Like if you can't understand, just I'll rewind the video, you'll be understanding it more. So what is torque here? Tau is equal to force into perpendicular distance F into BC. What is BC? We have found BC to be as
2a sine theta. So now we're going to substitute this value here. So that means the torque becomes F into 2a sine theta. For more convenience, I'm going to rub this diagram. So F is equal to 2a into sine theta. Now, what is this F? What is this F? F, we know that F can be marked as E into Q. Since we know that E is equal to F by Q, F can be termed as E into Q. Now we are going to substitute this value here. So that means tau is equal to E into Q into 2a sine theta. We just learned that Q into 2a is P. So what is it? That is E into P into sine theta. Since the angle that comes here is to be sine theta, it can be taken as a cross product of E and P. So that means tau is equal to P cross E. Now it became vector. All the quantities are now in vector form. So now we take the cross product of these two vectors, that is P and E, that is dipole moment and electric field. So what is the torque in and dipole when it's placed in an electric field? That is tau is equal to P cross E, or tau is equal to P into E into sine theta, or other form is F into 2a. Any of these formulas can be useful. So this is what happens when a dipole is placed in a uniform electric field. I hope you understood. Just please look back and just make sure that you are understood and clear with this video. So thank you.
I hope you understood the video. If you have any sorts of doubt, just please rewind the video and note the points down for more clarity. And if any other doubts are remaining, please comment below. I'll be replying your comments. And please don't forget to subscribe my channel and hit that bell icon so that you get notifications when I upload my new videos. So please like, share and subscribe. You can follow me on Instagram at Inspired Physics. So thank you, stay home, stay safe and keep learning.